Hello world, good morning, good afternoon, good evening. Welcome back to codingscientist.com. You are watching Hero to Superhero series, programming artificial neural network using Python and Visual Studio IDE. Alright guys, so let's move on. I'm going to open up my IDE and let's see where we are. Alright, so we are into a different magnitude of artificial neural network. So we are basically, going through the error back propagation. In the previous lesson, you learned about the error forward propagation, as well as we also talked about the transfer derivative, error back propagation, and stuff like that. But in this, you are going to see the actual code, how it works, right? So basically, the first step is to calculate the error for each output neuron. So what does that means? This will basically give us our give us our error signal, which is the input to propagate the backwards through the network, right? So it's a kind of error signal which works within the neural network between the input layer, the hidden layer, and the output layer, right? So basically the error for a given neuron can be calculated like, for example, error equal to output minus expected, right, multiplied by transfer underscore derivative as an output, right? That's the thumb rule formula which is being used, right, where expected is the expected output value of the neuron, output is the output value for the neuron, and the transfer underscore derivative function, the user defined function which we create, and that actually calculates the entire slope of the neuron's output value, right? So that's how this actually works. So basically this error calculation is used for neurons in the output layer, right? So the expected value is the class value itself, right? So you are creating an object and a class value, so that's how it works. In the hidden layer, things are a little more complicated. We really don't know, we haven't really explored. Probably I'm not an expert, maybe there are ton loads of brilliance of scientists in the world who knows exactly what happens in the hidden layer. I don't know, I'm sorry, but what I know is the error signal for a neuron in the hidden layer is calculated as the weighted error of each neuron in the output layer. So think of an error traveling back along the weights of the output layer to the neurons in the hidden layer, right? From the output layer to the hidden layer before the input layer, right? So the back propagated error signal is basically accumulated and then used to determine the error for the neuron in the hidden layer, which is nothing but error equal to weight underscore k multiplied by error underscore j, right? And then again multiplied by transfer underscore derivative, which is the output, right? It's as simple as that, guys. You are from MLDL AI industry, so you should understand all these formulas and stuff like that, right? So I don't have to explain this. So now, where error underscore j is the error signal from the tan h neuron in the output layer, whereas the weight underscore k is the weight that connects the kth neuron to the current neuron. Well, it's confusing, isn't it? Well, anyways, forget it. Now, this particular function backward underscore propagate underscore error, which you can see in the code, that implements this particular procedure. Now you can see that the error signal is calculated for each neuron is basically stored with the name called delta. That's what we are defining. Neuron in the square bracket, you can see delta with the open and close parenthesis, right? You can see that the layers of the network are iterated in reverse order, now starting at the output and working backward. Why? Because we need to look at the errors what has been populated and correct those errors, adjust the weights from the input. That's how it works. Now this ensures that the neurons in the output layer have the delta values calculated first, that the neurons in the hidden layer can use the subsequent iteration, multiple iterations of training happens, right? The training the data sets. Now I chose the name delta to reflect the change the error implies on the neuron. For example, the weight data, you can name it as delta, gamma, sigma, whatever you want. It's up to you. Now you can see that the error signal for neurons in the hidden layer is basically accumulated from neurons in the output layer, where the hidden neuron number j is also the index of neurons weight in the output layer. Now where it is, you can see at the bottom, this is where the actual magic happens, from here, from this line to this line. This is where the actual magic happens, where you are correcting the mistaken neurons which comes back from the back propagation, and then you fix the weights and then take it forward again for the next iteration of training from the input layer to the hidden layer and the output layer of the artificial neural network. Now, that's all about it, guys. It's pretty straightforward and interesting, so I hope you understand. I'm going to leave all this code in my GitHub. Pick it up and try to practice, understand line by line code. In the next lesson we will get more deeper into this. I will see you soon. Goodbye.